In this video, we look at collecting like terms. We use collecting like terms to simplify mathematical expressions. Makes things a little bit easier to work with. So generally, terms are separated by plus or minus signs. So here's a mathematical expression. It's an equation, has an equal sign. 3x plus 2y equals negative 4z. All three of these parts that are circled are terms. The 3x is a term, the positive 2y is a term, and the negative 4z is a term. Now, one thing to note here is that the sign in front of the term belongs to that term. So make sure you keep them together, and you'll see why in a moment. Alright, so like terms are terms, but they have the same variable parts, and this part's really important. But they also have the same exponent on those variable parts. So let's have a look at some examples. So here are three like terms, 3x, negative 15x, and 0.5x. They all have x's in them. The x's all have the same exponents. There are no exponents written here, so the understood exponents are 1. So these are like terms because they have the same variable part with the same exponent. Here's another example of like terms. All of these terms have x squareds in them, but they also have y's. So there's an x squared y here, x squared y here, and finally an x squared y here. So these are all the same. These are all like terms. If we had a term here that was 5xy, that wouldn't be a like term because it doesn't have an x squared. When we add or subtract like terms, basically what we want to do is just add or subtract the coefficients of those terms. And here's an example that I think most of you will be able to relate to. If you have 3 cookies and 2 apples, 2 more cookies and 4 apples, we might write that like this: 3 cookies plus 2 apples plus 2 cookies plus 4 apples. The coefficients are the numbers. In this case, the 3, the 2, the 2, and the 4, the numeric part of each of those terms. So those are the coefficients. Now, if we want to add these together, we're going to collect the like terms. So we're going to group the like terms together. So we're going to take the cookies and put them together. 3 cookies plus 2 more cookies. We're going to take the 2 apples and put them together with the 4 apples. So we get an expression that looks like this. Once we have this expression, we can simplify this expression by adding or subtracting the like terms. And we do that by adding or subtracting the coefficients. We take the 3 cookies plus the 2 cookies and add them together. We get 5 cookies. The 2 apples plus the 4 apples gives us a total of 6 apples. And that's all there is to adding and subtracting like terms. Again, just a reminder that the sign in front of the term must go with the term. So here we took the cookies and we moved them around, these 2 cookies. We moved the cookies together. We must move the sign together with it. So here's the plus sign. It moved with the 2 cookies. And we'll see an example in a moment where that's maybe a little bit different. So let's have a look at this one. Simplify this. Why don't you take a minute, pause the video, and just kind of work your way through and see how it turns out. Alright, hopefully you've had a chance to look at this one. The like terms, there's a negative 5a here and a positive 7a over here. Again, the like terms we want to move together with the sign that they go with. So this plus 7a, I'm going to move over to the group all the a's together. So here's the minus 5a. We've got the positive 7a. There's a 12b here and a negative 4b. We'll group those together. And once we have the like terms grouped, we can add or subtract them. Negative 5a plus 7a. Negative 5 plus 7 is 2. And then finally 12b, take away 4b, is 8b. This is as far as we can go. 2a and 8b are terms, but they're not like terms. They don't have the same variable part. So we stop right there. Let's have a look at a slightly different example. In this example, we have some p squareds and some p's. We're going to group the like terms together. So here's a p squared term. We need to find another p squared term. Here it is right over here. Don't forget that negative 7 is part of the p squared term. So we're going to group those square terms together. 3p squared minus 7p squared. And then we can group the p terms together. The 9p and the minus 4p. So we group those together and we get this. Now if you group the p's together and you had them first on the left side here and the p squareds on the right side, there's nothing wrong with that. It's still correct and you can go from there. So let's have a look and see what we get here. 3p squareds, we're going to take away 7p squared. So 3 minus 7 is negative 4, and those are p squareds. And then 9 minus 4 is 5. Those are p's. So we get positive 5p. We can't go any further because the p squared term here and the p term are different. They have the same variable parts, but not the same exponents. That's as far as we can go, so we just leave it as it is. Now the other thing here that we might be asked to do is to evaluate. So we might be asked to evaluate example A, this one up here. If A is 2 and B is negative 4, we could take this A equals 2 and substitute it into the original expression everywhere we see an A, and take the negative 4 for B, sub it in everywhere we see a B, and simplify afterwards. Or we could substitute into our simplified expression, and that's part of the reason why we want to simplify. It makes some of the work a little bit easier. So when we do the substitution, if A is 2, everywhere in this expression I see an A, I'm just going to replace it with a 2. There it is. And everywhere I see a B, I'm going to replace it with a negative 4. And then from there, it just becomes a matter of evaluating. 2 times 2 is 4. 8 times negative 4 is negative 32. 4 plus negative 32, that's the same as 4 minus 32, which gives us negative 28. So that's how we can collect like terms and a little bit of information about like terms. Thanks for watching.